Welcome to this session. This session, we are going to do a problem involving solving differential equation by matrix method. So the problem is to find the solution by matrix method of d cubed y dx cubed minus 5d squared y dx squared minus 2 dy dx plus 24y equals to 0. So what we have to start by is to reduce this cubic or third order differential equation into a system of first order differential equations. And then from that system, we get the equation, the vector equation, y prime or y dot, y prime equals to a y, and then get the eigenvalues of a, eigenvectors of a, and then get the linear combinations of the three solutions to get the solution to the differential equation. This is what I meant. So start by saying, let solution, let y be another variable y1, so which implies y dx is the same as dy1 dx, which you let this, the first derivative of y, or y1 to be y2. Call this one equation 1. Now you see, when you differentiate this one again, you get d squared y dx squared, which is the same as d squared y1 dx squared, the same as dy2 dx. So dy2 dx, let it be y3. Call this one equation 2. I remember dy2 dx is differentiating this equation again, so that we have d dx of dy dx is the same as d dx of dy1 dx, this point here, which is the same as dy2 dx, just differentiating both sides of this equation. So this is what defines d squared y dx squared is the same as dy2 dx. So this one here will be defining the second derivative. Now you see this equation, so which means that now the d cubed y dx cubed can be made the subject of this equation. And so differentiating this one again, we'll have dy3 dx is the same as d cubed y. This should be clear because when you differentiate both sides of this equation, so we'll have d dx of dy2 dx is the same as dy3 dx. This is the same as d dx. Remember, dy2 dx is the same as d squared y dx squared. Now, when you differentiate the second derivative, you get the third derivative. So that's why I'm saying dy3 dx is the same as d cubed y dx power 3. And then from the given equation, this will be the same as, take this to the right hand side will be positive, d squared y dx squared plus 2 dy dx minus 24 y. I'm simply taking these terms to the right hand side so that I make the third derivative of y with respect to x the subject. Now, remember, this is the same as d squared y dx squared. So where there's d squared y dx squared, you can replace by y3. So this, like I have here, is y3. And dy dx is the same as y2. So this is like I have 5 and then plus 2 y2 and then minus 24. Where there's y, you put y1. And this is dy3 dx. So call this one equation 3. So now you see we have been able to reduce the third order derivative into a system of 3 first order derivatives. So let me just put them together. So we have dy1 dx can be written as 0y1 plus y2 plus 0y3. Because this is how we gave it. It was y2. So I can just include this by multiplying by so that we have all the 3 variables. And then dy2 dx from here is 0y1 plus 0y2 plus y3. And then from this one here, dy3 dx is equals to minus 24y1 plus 2y2 plus 5y3. So this is the system that now we need to solve. And you see this is the same as writing dy1 dx, dy2 dx, dy3 dx, and then equals to so I have 0, 1, 0, 0, 0, 1, minus 24, 2, and then 5. This is y1, this is y2, this is y3. So this is the y prime equals to a times y. So where y is this vector, this a matrix, then this is a vector of the derivatives. So therefore, once we have successfully written the system of 3 linear differential equations, and we have this equation y prime equals to a y, then we get eigenvalues of the matrix A. So remember, we need to solve A minus lambda I should give us 0. This will be, so A is, remember, A matrix is given by 0, 1, 0, 0, 0, 1, minus 24, 2, and then 5. So when you subtract lambda I, so just have 0 minus lambda, 1, 0, 0, 0 minus lambda, 1, minus 24, and then we have 2, 5 minus lambda. This would give us 0. And this is the same as writing determinant of minus lambda, 1, 0, 0 minus lambda, 1 minus 24, 2, 5 minus lambda equals to 0. So that we use cofactor method to find this determinant. I remember I want to use the first If I use the first row, this sign is plus, minus. So the assumption is that you know how to get determinant of a 3 by 3 matrix. So this one will be minus lambda, determinant of, delete this row, delete this column. So we have minus lambda 2, 1, 5 minus lambda, minus 1, delete this column, this row, 0, 24, 1, 5 minus lambda. Then this will be 0 times this submatrix, and then so that will just give us 0. So we'll have negative lambda into, this will be lambda squared minus 5 lambda minus 2 minus 1. 0 times this is 0. 24 times 1 is 24. Now minus lambda cubed plus 5 lambda squared plus 2 lambda minus, so this is plus now, minus will be now plus 24 equals to 0. So remember this was negative here. So this is negative 24, so which means this is plus. So the sign here will be minus. Because here we had this element is minus 24, not positive 24, so correct that. So this is negative. So then here we'll have minus 24. Was 0 minus minus 24, that's for that positive here. Or dividing through by negative, we'll have lambda cubed minus 5 lambda squared minus 2 lambda plus 24 equals to 0. Now, this is a cubic equation. There is no straightforward formula to solve a cubic or to factorize a cubic expression. We do by trial and error. And the trial and error is done using this constant term. So you take your constant term and list its factors. So factors of 24, we have 1, plus or minus, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24 itself. So it's by trial and error. Try to see which values of these factors, when you put into the equation, it satisfies the equation. Simply means that if you evaluate the left-hand side, you get 0. So assuming I try with 1, so if I put 1 here, I'll have 1 minus 1 times 1 squared times 5 is minus 5. So 2 and 24. So minus 4 minus 2 plus 24. Obviously, this will not be 0. So 1 is not a factor. If I try negative 1, I'll have negative 1 minus 5 plus 2 plus 24. This will be 26. 26 minus 6 is not 0. So also 1 and negative 1 are not factors, or cannot be the values of lambda to satisfy this equation. If I try 2, I'll have 2 cubed is 8 minus 2 squared is 4 times 5, 20. 2 times 4 is 2 times 2 is 4, and then plus 24. So 24 plus 8 is 32. 32 minus this is 24. This is still not 0. So 2 is also not a factor. If I try minus 2, so this will be minus 8 minus 2 squared is 4. 4 times 5 is 20. Minus 2 times minus 2 is plus 4, and then plus 24. Now 4 plus 24 is 28. So minus 8 minus 20 plus 28. Actually, this will give us 0. So that means lambda equals to minus 2 is a solution to this given equation. Now, when lambda equals to minus 2 is a solution, then it means that lambda equals to minus 2 is a root of, let me call this one star, equation star, means now take this to the right, we'll have, to the left will be lambda plus 2 is a factor of now this left-hand side, minus 5 lambda squared minus 2 lambda plus 24. That's the implication. So we use long division to get the other factor. So lambda cubed minus 5 lambda squared minus 2 lambda plus 24, lambda plus 2, lambda into lambda cubed is lambda squared. So what you multiply by lambda to get lambda cubed is lambda squared. So lambda squared by this is lambda cubed. Lambda times 2, lambda squared times 2 is 2 lambda squared. And then you subtract in the usual way. Lambda cubed minus lambda cubed is 0. Minus 5 lambda cubed, lambda squared minus 2 lambda squared is minus 7 lambda squared. Then you bring this minus 2 lambda, then plus 24. What you multiply by lambda to get minus 7 lambda squared is minus 7 lambda. So that would be minus 7 lambda squared. Minus 7 lambda times 2 is minus 14 lambda. And then you subtract. Minus 7 lambda squared minus 7 lambda squared is 0. Minus 2 lambda minus 14 lambda. So it's like we have 2 lambda, minus is plus, minus 2 lambda, minus is plus 14 lambda. This will give us 12 lambda. So 12 lambda, bring this 24. Now, the number we multiply by lambda to get 12 lambda is 12. So 12 by lambda, we get 12 lambda plus 24. And if you subtract, we get 0. So that means lambda plus 2 times lambda squared minus 7 lambda plus 12. When you multiply this, you get lambda cubed minus 5 lambda squared minus 2 lambda plus 24. So let's factorize this. Lambda squared minus 7 lambda plus 12. This is a quadratic expression. Product is 12, sum is minus 7, and numbers should be negative 3 and minus 4. So that you'll have lambda squared minus 3 lambda minus 4 lambda plus 12 will be the expression lambda squared minus 7 lambda. So this, you do the pairing, lambda into lambda minus 3 minus 4 into lambda minus 3. So lambda minus 3, lambda minus 4. So which means this part can be written as a product of these linear terms. So therefore, lambda cubed minus 5 lambda squared minus 2 lambda plus 24 is equals to lambda plus 2 lambda minus 3 lambda minus 4, and this was equals to 0. And you see, we'll have lambda plus 2 equals to 0, or lambda minus 3 equals to 0, or lambda minus 4 equals to 0. So this implies lambda 1 is minus 2, lambda 2 is 3, and lambda 4, or lambda 3 is 4. Those are the eigenvalues. Let's now get the eigenvectors. Eigenvectors. So for lambda 1, which is negative 2, so when negative 2, so we have to solve, because this now is a 3 by 3 matrix, our A in this case, which is 0, 1, 0, 0, 0, 1, minus 24, 2, 5, is a 3 by 3 matrix. So it means our eigenvectors should be in 3D. So we'll have x1, x2, x3. So we need to solve the equation A u1 equals to lambda 1 u1. So that we'll have 0, 1, 0, 0, 0, 1, minus 24, 2, 5, times x1, x2, x3 equals to minus 2, x1, x2, x3. And then left-hand side will give us 0 times x1 is 0, 1 times x2 is x2, so we'll have x2, 0 times x1 is 0, 0 times x2 is 0, this will give us x3, and then this other one is the negative 24x1 plus 2x2 plus 5x3 should give us negative 2x1, negative 2x2, negative 2x3, from which this implies x2 should be negative 2x1, quality equation 1, x3 should be negative 2x2, quality equation 2, and minus 24x1 plus 2x2 plus 5x3 should be minus 2x3. Call this one equation 3. Now, this is a very easy system to solve because equation 1 and equation 2 can help us to get all the values of x1, x2, x3. So from 1, let x1 be t, where t is a non-zero real number. Then it implies x2 equals to minus 2t. So we have the values of x1 and x2. Now, using the value, this value of x2 in equation 2, we get x3 is minus 2, but where there's x2, we put minus 2t, which will give us 4t. So we have all the values of x1, x2, and x3. So therefore, u1 is x1, x2, x3 is given by x1 is t, x2 is minus 2t, x3 is 4t, which can be written as 1 minus 2, 4t, and this t is a non-zero real number. So letting t to be 1, then u1 will be the vector 1 minus 2, 4, And therefore, the x1, the first solution, x1 of y1, because actually the equation is in terms of y. So y1, the first solution, y1 of x, because the problems in terms of x, is e raised power lambda 1 x u1, which should be e raised power. This was negative. This vector was for lambda 1, which is negative 2. So we have negative 2 x into 1 minus 2, 4. And then lambda 2, the second eigenvalue in this problem was given by 3. So a u2 equals to lambda 2 u2. And so we have our A matrix 0, 1, 0, 0, 0, 1, minus 24, 2, 5. So let U2 be U1, U2, U3. Then 3, U1, U2, U3. So that this product will give us U2, and then this will be U3 minus 24 U1 plus 2 U2 plus 5 U3 should be 3 U1, 3 U2, 3 U3. And from this equality means U2 should be 3 U1, U3 should be 3 U2, and minus 24 U1 plus 2 U2 plus 5 U3 should be 3 U3. So call this one equation 1, call this one equation 2, call this one equation 3. And from 1, if we let U1 to be t, then U2 would be 3t. And using this value in this equation, U3 will be 3 into 3t, which will be 3 by 3 is 9t. So the first and second equation help us to get all the values of U1, U2, U3. And so we'll have U1, U2, U3, which is the vector U2 is U1 is t, U2 is 3t, U3 is 9t, which is 1, 3, 9 t. And when you let t to be 1, t equals to 1 implies that U2 is 1, 3, 9. So the second solution, y2 of x, by definition is given by u e raised power lambda 2 x times u2, which is e raised power 3 x, and u is 1, 3, 9. 1, 3, 9 is the solution for that. And then lastly, lambda 3 given by 4 will be A U3 should be lambda 3 U3, this value eigenvector relation. So A is 0, 1, 0, 0, 0, 1, minus 24, 2, 5. And then let U3 to be V1, V2, V3 equals to 4. And let this one be V1, V2, V3. So the interest is to find the values of V1, V2, V3. So 0 by V1, so we have V2, V3, and then minus 24 V1, 2 V2, 5 V3 equals to 4 V1, 4 V2, 4 V3. And from this, for this equality to make sense, then V2 should be 4 V1, V3 should be 4 V2, and minus 24 V1 plus 2 V2 plus 5 V3 should be 4 V3. So call this one equation 1, call this one equation 2, call this one equation 3. Now from 1, if we let V1 to be t, then V2 will be 4t. And using that value in this equation, V3 will be 4 into 4t, which will be 16t. So the vector U3 will be V1, V2, V3, which is V1 we have let it to be t, V2 is 4t, V3 is 16t. And when you factor out t, you get 1, 4, 16, then t. And letting this t to be 1, then U3 is given as 1, 4, 16. So that is our U3, 1, 4, 16. Now that helps us to get the solution for the third solution. So that means that Y3 of x is given by e raised power lambda 3x times U3, which is e raised power 4x, and then 1, 4, 16. So then lastly, there by superposition principle, the solution, the general solution is y of x is given by c1 y1 of x plus c2 y2 of x plus c3 y3 of x, which would be y of x is equals to c1 y1. Our solution was e raised power minus 2 x into 1 minus 2, 4 plus c2 e raised power 3x, and then that vector was 1, 3, 9 plus c3 e raised power 4x. The vector in the third case was 1, 4, 16. Now, this is the same as writing y of x is given by C1 e raised to power minus 2x plus C2 e raised to power 3x plus C3 e raised to power 4x minus 2 C1 e raised to power minus 2x plus 3 C2 e raised to power 3x plus 4 C3 e raised to power 4x 4 C1 e raised to power minus 2x plus 9 C2 e raised to power 3x plus 16 C3 e raised to power 4x. Now remember, the way this capital Y is interpreted is that this is the function Y of x. This second row is a derivative, first derivative of the function Y, and this one is the third derivative of the function Y. So the general solution of the given equation, you pick the first row. So therefore, the general solution to the given differential equation is what we have in the first row. Is given by y of x equals to C1 e raised to power minus 2x plus C2 e raised to power 3x plus C3 e raised to power 4x. So that is the solution to that given question. If you are given the initial conditions, then we can get the values of C1, C2, and C3. Thank you.